Welcome to part 2 of EasyGov's EoI-EoE model video series. EasyGov's EoE-EoI model focuses on ensuring the right beneficiaries get the benefits, and by right, we mean eligible, verified, and the most needy beneficiaries. Our model is inherently AI and data-centric and utilizes advanced calculations to correctly identify the correct beneficiaries according to the respective projected EoE and EoIs of 3 different types of need scores. The 3 types of scores to calculate EoE and EoI are scheme-specific need score, welfare type-based score, and the socioeconomic need score. Let's begin with the scheme-specific need score. Scheme-specific need score is a score that only gives us the error of inclusion for a particular scheme for the user. This need score helps provide recommendations to the government on policy by identifying individuals that should have not been eligible for a scheme. Such recommendations can be based on further deep analysis of the scheme-specific need score, taking into consideration errors based on benefits, time, etc. An example would be the scheme-specific need score for the Manrega scheme, coupled with the benefit amount that a person has received from Manrega in the past or is currently receiving. If the beneficiary is receiving benefits from multiple schemes, then instead of looking at scheme-specific need scores or specific schemes, we'll group the schemes into welfare types and instead assess the welfare type-based score and the amount our benefit received from a welfare type. Welfare type-based score is the score that gives us the error of inclusion and exclusion for a particular welfare type for the user. These welfare types are one of the following 5: housing need score, health need score, education need score, food need score, livelihood need score. All schemes are generally mapped with their respective user types, and a score will be calculated for each welfare type for a user, allowing users to have a unique score for each welfare type. Aside from providing analytics based on time and benefits, welfare type-based score also helps analyze progressive growth and assists with calculations of sectoral error of exclusion and inclusion. This means that we can determine errors specific to each department and analyze them deeply to provide policy recommendations per department. If the beneficiary is receiving benefits from multiple welfare types, then instead of looking at the welfare type-based scores individually, we can group them and look at the socioeconomic need score or the overall need score. Socioeconomic need score is the score that tells us the overall performance of welfare and provides analytics based on 2 dimensions: time and the overall benefits. Each user gets assigned a socioeconomic need score, which helps determine how much a user is in need of welfare services. An example would be comparing the past socioeconomic need score to the current socioeconomic need score of a user. However, socioeconomic need scores can provide better insights after combination with another metric, such as DBT. Socioeconomic need score also provides analytics to gauge indicator trends and find out worst and best performers. The government can use the score at a macro or aggregate level to assess the overall effectiveness of the social welfare approach, the possibilities to explore, and various related policy decisions. Let us now take a look at our model's needy score dashboard for these scores. The EasyGov system calibrates the socioeconomic, welfare type-based, and scheme-specific need scores using our data-oriented needy score dashboard and the total benefit a user has received over the course of his/her life. Our needy score is calculated using our explainable AI model, as also explained in a previous video. We calculate the same by first identifying socioeconomic parameters to base need on, such as house value, house type, amenities, location, family income, etc. After that, we create a structured residence profile graph by arranging the parameters given. The graph helps in building a profile for an individual or family, by identifying or calculating values that are required to determine a family's or individual's profile. A graph is then created by merging subgraphs of all the major socioeconomic parameters to create a family profile, which is known as an inference graph. It helps our AI system recommend benefits based on a multi-dimensional view. Once this structure is built alongside the nodes and links to the graph, a probability distribution will be assigned to each node based on our expert domain knowledge, which will help determine the needy score for an individual or a family. Continue to part 3 to watch EasyGov's EoI-EoE model along with the needy score dashboard in motion. Visit our website at www.easygov.co.in for more information.